Alrighty, so what we're talking about today is once we are given certain pieces of information, how do we come up with a quadratic function from that piece of information, okay? So for our first example, we have a graph. What you want to be paying attention to is where the solutions are and what the solutions are. So what are the solutions of this graph, of this parabola? All right, so the first thing we're going to do is determine our solution. So we have x equals -5, and we have x equals -2. All right? Next thing we're going to do is turn those solutions into factors. Okay? How would I turn this into a factor? Yeah, get it equal to 0. So I would have to add 5, and I would get x plus 5 equals 0. What would I get on this one? X plus 2 equals 0. Okay? Then, in order to actually get our equation in standard form, we are going to take our factors and multiply them. So x plus 5 times x plus 2. All right. This is factored form, but we want it in standard form, so what are we going to have to do? Yeah, go ahead and multiply it. X times x is x squared. 2x plus 5x is 7x. 5 times 2 is 10. You could have it equal to 0. You can also write this as y equals x squared plus 7x plus 10. Either way is fine. It's asking you for an equation in standard form. So it's got to be an equation. It can't just be an expression. Okay? Uh-huh. Okay. Excuse me. Those directions to write a quadratic equation in standard form are for all the notes. Okay? So stick with those same directions. And this time we're just told that we have zeros at -3/4 and 2. So we want to follow the same process that we did on number 1. Go ahead and write it as a solution. So x equals -3/4 and x equals 2. Then what do we want to write it as? Factors. So we've got, how would I get this as a factor? Yeah, I would add 3/4 to both sides. So x plus 3/4 equals 0. What about this one? X minus 2 equals 0. Okay, and then what am I going to do? Not factor them. Yeah, we're going to multiply them. Yeah. Hmm? All right, let's go ahead and multiply. So we're going to have x squared minus 2x plus 3/4x. 3/4 minus times -2. What's that? Yeah, -6/4, which reduces to -3/2. All right, oops, sorry, I forgot an x there. So let's combine like terms of, let's combine -2x and 3/4x. What do we get there? Good, -5/4. So we have x squared minus 5/4 x minus 3/2, and then equals 0, or we can put y equals in front. doesn't matter to me. Okay, the only x-intercept is at x equals negative 6. So what does this tell us about our function? One solution. Okay, well, all these are something squared. What do you mean by something squared? Oh, okay, it's one binomial squared. I'd agree. Specifically, what would the graph look like? Yeah. At x equals negative 6, where that one solution is, there's my vertex. And as Jenna said, that's going to be a binomial squared. Well, think about writing this in vertex form. It would be y equals what? Yeah, x plus 6 squared. Because my vertex is at negative 6, 0. Do y'all see that? Okay. Can we leave it like that? No, we're going to need it in standard form, so we need to multiply that out. So I would get x squared plus 12x plus 36. Okay. The reason that it's a binomial squared is that root of negative 6 is what we call a double root. That's what causes the graph to come down, hit the x-axis, and bounce off. So even though we say that there's one real solution, a more accurate term would be one distinct solution. Because technically, negative 6 is a solution twice. Its factor is x plus 6 and x plus 6. So technically, it is a solution 2 times. But when we say two solutions, really what we're saying are two distinct solutions. Okay? All right. Go ahead and write this down. Let's look at a complex solution. Okay, we're going to set it up the exact same way. So go ahead and write them as two separate solutions here. So x equals negative 2 plus 3i. And x equals negative 2 minus 3i. And let's get them solved for their factors, or get them written as their factors. So how would I write this first one? Good. And then this one would be? Great. Okay. So just like the other ones, we found our solutions. We wrote them as factors. Now we're going to multiply. So go ahead and write these out. Yes. All right, for this, we're going to have to triple distribute. So you're going to start by distributing this x to each piece. So what would that give me? X squared plus 2x plus 3ix. Well, you just remember, like, I is a number. It's not a variable. It is something that we know. So x is your variable, so you put it with your coefficient of that variable. Okay? All right, now let's distribute that 2. What's that going to give us? All right, and lastly, let's distribute our negative 3i. So we've got minus 3ix minus 6i. What's negative 3i times positive 3i? Minus 9i squared. Questions on that? All right, what do you notice? Yeah, things start canceling. That has to happen. In your final standard form version of your equation, you cannot have i's or radicals, okay? It's got to cross off. If it doesn't, go back and try again. So 3ix and negative 3ix, positive 6i and negative 6i. And how could I rewrite negative 9i squared? Good, so let's rewrite what we have. All right, combine like terms and write it as an equation. What questions do you have about that? Okay, let's try again. One plus or minus I root 5 over 2 are my two solutions. So I'm going to split it up and write it as two separate ones. X equals 1 plus I root 5 over 2. And x equals 1 minus I root 5 over 2. In both these situations, what are we going to do first? Yeah, multiply by 2. So I'm going to have 2x equals 1 plus I root 5. Then what am I going to do? Yeah. So I have 2x minus 1 minus I root 5 equals 0. All right, go ahead and do the other side. Multiply by 2. I have 2x equals 1 minus I root 5. 2x equals negative 1. Oops, sorry. 2x minus 1 plus I root 5 equals 0. Okay, so we've rewritten them as factors. Now what are we going to do? Multiply them. All right, so we're just going to distribute piece by piece. So let's start by distributing my 2x. What would I get? 4x squared. Keep going. Minus 2x. I could write this one as plus 2I root 5x. I mean, no, I guess nothing awful is going to happen to you if you don't. That's just the order that it would go in. Okay, distribute that negative 1. So minus 2x plus 1 minus I root 5. And then distribute your negative I root 5 minus 2 I root 5x plus I root 5. Okay, then we have minus I root 5 times I root 5. Okay, let's break it down a little bit more than that. Square root of 5 times the square root of 5 is 5. Negative I times positive I. This is going to be minus 5I squared. All right, so remember, you don't want any i's or radicals in your answer. So hopefully all of them cancel. If they don't, you want to go back and try again. What is minus 5I squared? So this is going to be 4x squared minus 2x plus 1 plus 5. Which gives me what? Not minus 2x. minus 4x. Don't forget your y equals, okay, it's an equation. Questions on that? Alrighty. Let's see what happens when we've got 3 points that we want to deal with. Trust me, it will be fine. No. Can we look at the problem? Okay. Tells me that there are solutions at 3 and at 8, and another point that the parabola passes through is 2, 3. Does it tell me that 2, 3 is a solution? No, it's just another random point on the parabola. So right now we have 3 points on the parabola. Let's write out those 3 points. What are they? Okay. And 2, 3. All right. Just like you can determine a line through any 2 points, you can determine a parabola through any 3 points. Okay? And our calculator is going to help us do this. So, open up your calculator. Open up your calculator. Go to Stat. Once you're at Stat, which is this button right under Delete, once you're in Stat, you need to select Edit. In List 1, you need to put your X values. And in List 2, you need to put your Y values. Everyone have that? Okay. Then you're going to press Stat again. Arrow over to Calc. And instead of doing linear regression, we're going to do quadratic regression, which is number 5. And then you press Enter. Okay. So after you put your data in the list, you press Stat again, arrow over to Calc, choose 5, quad regression. Okay? All right, so let's write our equation. In this case, yep, it sure is. So y equals 0.5x squared minus 5.5x plus 12. All right, please go ahead and try number 7 on your own. There is a solution at negative 2/5. Try again. You did 3/5, not 2/5. All right. What'd you get? Minus 24. All right. Let me explain to you a little bit about what your calculator is doing. Okay? If I have a solution at negative 2/5, I have the point negative 2/5 comma 0, right? Okay. The equation of in standard form of a quadratic is ax squared plus bx plus c equals y. So what your calculator is doing is it's setting up a system with 3 equations where it plugs in your x and your y values. So the first one from this equation would be a times negative 2/5 squared plus b times negative 2/5 plus c equals 0, because that's my y. Okay? Then it plugs in these other 2 points, negative 130 and 0, negative 24. Once it has 3 equations of 3 variables, can't we use a system to solve that? Okay? You could take that and put it into the matrices. Okay? Put it into matrices, and your answer that you get out is going to be your coefficients, A, B, and C. It's exactly what your calculator is doing when it gives you the quadratic regression. Okay? Does that make sense? All right, cool. That's all I have for you today. I'll pass out your homework.